Now I have another very, very interesting topic for all of you. I would love to invite Mr. Navendu Pottekkat. He is a developer advocate from API 7.ai, and he will be taking us to the journey of practical introduction to open telemetry tracing. Navendu is a maintainer of Apache API SIX. He is a developer advocate at API 7.ai. He is a mentor at Google Summer of Code and LFX mentorship program. He is also an amateur policy analyst and a serial volunteer. A big round of applause for Navendu. It's my privilege and honor to have you on stage. And over to you, Navendu. Those who are still left to scan the code, please scan the code and you can answer and you may win a prize. There are 3 prizes for that. Over to you.
Thank you for the introduction and thank you to our previous speaker. Actually, the last word before the thank you slide was observability, and that's where we are starting today, specifically tracing in observability. So I know, I had a very heavy lunch. I expect you also had a heavy lunch and you're all tired. So I'll keep this session light. Our goal is to learn about tracing, just to get introduced to what tracing is, what open telemetry is. And our goal is not to walk out of here in 30 minutes becoming an open telemetry expert or observability expert. So we'll keep our expectations short and we'll see where it leads us. So this talk will have very less takeaways. The idea is that you can build upon it after this session. All right, so initially we had our monolithic applications. It was simple. We had one giant applications and all of your client applications were talking to it. And then we moved on to microservices. So I think we are at this point, at least even if you don't embrace microservices, you are at least somewhere here. So you have your client applications, you have a reverse proxy serving that application, serving the backend app, which is talking to a database. So at least we have something like this, which could be called as a distributed monolith. So in such scenarios, where we have moved to microservices, where we have moved to such distributed architectures, monitoring and observability is not just a good idea, but it is a requirement. I guess that was also the point of our previous speaker. And the greater number of components we have in our application, the stronger this requirement becomes. So there are 3 pillars of observability. So anybody know what they are? I can give you one clue, one is tracing. So what are the other 2 pillars? Correct answer. So you get a book. I only have one book, so okay. So metrics, logs, and traces. These are the three pillars of observability. So when we talk about metrics, things like CPU usage and memory come to mind. These are like the low-level metrics. But metrics could also mean things like requests per seconds or HTTP status codes, all sort of these high-level stuffs as well. And when you talk about logs and observability, the questions that we should ask is, what should we be logging? So uh, there are a lot of opportunities, there are a lot of areas, a lot of things you could log. Some of these might be useful, some of these may not be useful. So deciding what you should log is key. And then there is a question of where you should log. So it could be a file, it could just be the shell, it could be in a third-party provider like a log aggregator or some sort of service. And finally, who reads your logs? Like, is your logs are your logs meant for a human to read, or are they meant for machines? Should it be plain text logs, or should it be like JSON logs? So these are the questions that you should ask. But our main concern for today is tracing. So let's talk about traces. So basically, it gives us an aggregated view across all components. So you have multiple components in your architecture, and a trace gives you an aggregated view across all of these components. So this is an example of a trace. We'll dig deep into it in the demo session. But what you can see here is a trace, and it contains multiple components. So it gives you an aggregated view of the whole thing, and you can see like this has multiple components, and you kind of get an idea that this contains an aggregated view. So within traces, a trace follows the path of the request and spans multiple components, whereas a span is bound to a single component. And it is bound to another span in a parent-child relationship. So coming back to this entire trace, you can see the whole trace here in blue. And then you have multiple spans. So within our main request, you have multiple sub-requests. These are all spans. And each of these has children, which are another span. So what you see here is the time it takes to make this, like send this message and get back. So what you see here is multiple spans, and all of this combines to form a trace. So tracing seems important, and tracing seems like something that we want to do. So as engineers do, we create a standard for it. So we need a standard for tracing. So what does a standard for tracing look like? And so a standard should work across multiple technology stack. So you could write your backend in anything. You could have any sort of reverse proxy. You could have any sort of things, but it should work across technology stacks. And it should adhere to a specification. So standards are often accompanied with specifications, and it only makes sense if the standard has a particular specification. And that's exactly what trace context is. It's a World Wide Web Consortium recommendation. So it is a specification for tracing. And OpenTelemetry is an implementation of this specification. But it is not just the implementation, it does a lot more stuff. Like it provides SDKs so that like you can set up tracing. It also has a lot of APIs. It also comes with a lot of tools. And it is available in several programming languages. So you could say it is language agnostic. You can use OpenTelemetry to set up traces in anything. All right, so let's get to the interesting part. So we have, I wouldn't say microservices, but like let's say a distributed monolith set up here. So we have a client and we have an API gateway, which is like a reverse proxy with a lot of cool features. Uh, and then we have a Spring Boot application, a Java application, and it talks to a database. And the Java application in turn talks to a Python Flask application, and it in turn talks to a database. So our whole system is comprised of multiple technology stacks, and let's see how we can trace this. So a trace would mean tracing the request right from the point where it reaches the API gateway, which is the entry point to your backend services, all the way to the database and back. So I mentioned an API gateway, so we haven't really talked about that. So the API gateway mentioned here is Apache API 6, and I work on Apache API 6. So it's a high-performance cloud-native API gateway. It has a lot of features. It's a reverse proxy, but it has a reverse proxy with a lot of features. So it does load balancing, canary releases, circuit breaking authentication, observability, and a lot of stuff. So you can learn about it at api6.apache.org. Yeah. Okay, so back to our setup. So to export traces, to collect data for these traces, we have this setup. So API 6 has an OpenTelemetry plugin which exports data into OpenTelemetry format. And the Spring Boot application, it has a JVM agent. So one thing that is important here is that you could either set up traces automatically or you could do it manually. So this is an introduction session, so let's just start with the basics. Let's just start with the automatic stuff. So the JVM agent automatically exports some data, exports some relevant data in OpenTelemetry format for our traces. And we also have OpenTelemetry export options available for the Flask application, the Python application. So we will also use an automatic export option, automatic instrumentation option. But we will also look into how you can manually export data for your traces. So we will look at how you can configure API 6. We will look at how you can configure the Python application, the Java application, and then see the trace. Let's see. So I have this Docker Compose file which deploys everything that we talked about. And the tracing tool we use is Jaeger, but you can really substitute it with any tool that supports OpenTelemetry. That's the beauty of OpenTelemetry, because like any tool that implements OpenTelemetry, you can work with each other. So I use Jaeger because it was easy to set up. Then we deploy API 6. Then we deploy our Java application. Then we deploy our Python application. That's pretty much it. So to configure API 6, it's pretty easy. We need to add an OpenTelemetry plugin and set the address of the collector, which is Jaeger, and that's pretty much it. We also create a rule that says OpenTelemetry, we are enabling OpenTelemetry in API 6. So API 6 will keep on sending data to this OpenTelemetry collector. And for the demo, like let's say it's always on, you can always sample this to make it more efficient. Yeah. Then on our Java application, let's see. So, so in this Docker file, we install all the dependencies, we set the target, and then we add this Java agent. This is the agent that automatically exports or automatically exports the relevant data into OpenTelemetry format. So you don't have to manually specify what data you want in the trace. This just does it for you automatically. So we are doing this because this is just an introductory session, but you could always do this manually. And to do this manually, let's see. Let's see. Yeah. So we could also like instrument our Java application manually through uh, the OpenTelemetry Java SDK, and we can create our own spans. So we can manually specify what we want in the trace. We can manually specify the data we want in the trace, and so on. Now, going back to the Python application, it's something similar. So we have this Python tool, the OpenTelemetry instrumentation for Python, and specifically Flask, the Flask library, and then we will use that to run our Flask application. So this will automatically export some metrics as well. And similar to the Java application, we could also we can also like add our own trace, like manually add data to the trace. All right, let's see this in action. So I have these running, and if I make a request, ideally the tracing system we have set up, it will track how the request went through all of our applications, the API gateway, the Java application, the Python application, the databases, and back to the client. So let's see. All right, so we get a response back from the application. It looks correct. It's a valid JSON response. Now, if we go back to, if we open up Jaeger, so this is Jaeger, this is the tool we are using to visualize the trace. And let's see, let's find the traces in API 6 for the last 5 minutes. Okay, so we just ran this, and we find this trace here. So if we look into that, let's see. All right. So this is the entire trace, and as you can see, there are multiple spans. So this is a particular span, and as we go down, you can see there are multiple child spans as well. So the API 6 service, or the API 6 calls the order service, which is our Java application, which in turn calls the Python application, and that is what you can see here. So you see data on the latency and stuff, but you could also see the other data as well, which is also relevant. And when you are doing manual instrumentation, you could also add your own data that you think is valuable in the trace to this particular through the manual instrumentation tools, the SDKs, and it will show up here. This also so if there is an issue with your service, like if it is not communicating it, if the networking is wrong, you could identify it through a trace. So it shows the route, it shows the status code, it shows where the span started, it shows what caused the span, all sort of stuff. All right. So I guess we have a couple more minutes remaining, so I will open up to any questions. So if you don't have any questions, you can learn more about API 6 over here, but like, if you have any questions, and if I think I can answer, I will be happy to answer them. Yeah, thank you.
You need to give the book, I think.
Okay. So, any questions? Okay. Like, let's say Amazon load balancer. I'm not sure, but like maybe they have their own open telemetry exporters. So there is a particular format called, there is a particular binary format for exporting data into open telemetry format, and most of the tools out there, they have these integrations. So I guess it should work that way, but I'm not particularly sure. Yeah. Like it would be similar to how API 6 handles it. So API 6 is non-cloud cloud service provider API gateway. So it does the export similarly. Maybe, yeah, something. Oh, okay. Okay, then you should use API 6 instead. Any other questions? All right. So this book, I guess, yeah. So the book is about hybrid cloud infrastructure
We'll go up
and
on the stage.
operations. So hybrid cloud is something
Picture.
that you might be interested as well, because like you could have API 6
Easier.
deployed and then do stuff with Amazon as well. So yeah.
So congratulations for winning the book, and thank you so much, Navendu. It was a very, 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 very detailed presentation as well as the hands-on. It went off very well, and even I understood what you were explaining. Yes, yes, you're also on time early. Please be on the stage. And I request, yes, I request Kavita from JFrog to be on the stage and felicitate Navendu on behalf of Excellentro. So a big round of applause for Navendu for the wonderful, insightful presentation. Thank you so much, Navendu. Thank you, Kavita. So, yes, please, yeah, picture, yes. That's very important because we will cherish the memories throughout with these pictures. So audience, I'm sure all of you must have by now scanned the code, and you must have submitted your answers. And we will have the most interesting session for this event, which is the panel discussion now. So just give us